Today I want you guys to work on the mixed review for chapter 8.5 to 8.7. So as you can see, I have the quiz section up over here, questions 1 to 12. I want you guys to do as much of these questions first. So actually do them all. So your task today is to do all 1 to 12, and then when you're finished you can go ahead and continue watching the video and check the answers. And afterwards, once you're finished with that, I also want you guys to do the problem solving 2 pages after that page. So what you need to do is you will need to open up the PDF of the textbook and then find the problem solving questions 8.5 to 8.7. Do all 7 of them. So 1, 2, 3, 4, 5, 6, 7 questions. And once you're finished with those 7 questions, then again you can continue watching the video for the full solutions to the answers. Make sure you do check your answers. Give yourself a tick if you got it correct, and if you got it wrong, give yourself a small cross and circle the places where you made a mistake. It's important to identify your mistake. So at this point, please pause the video and do the questions now. So I assume you have finished doing all the questions. So I'm going to go ahead and check the answers. If you haven't, then again, I will say again, you have to do the questions first in order for you to benefit from this video. Okay, question 1 over here. I'm going to start doing the answers like this. Question 1, write the percent as a decimal and a fraction. So 43%, if you want to change it into a decimal, that's going to be 0.43. And then as a fraction, that's going to be 43 out of 100. And there is no more simplifying that can be done, I think. Let me just further check. Yeah, there's no more simplifying that can be done. Question 2, 97% as a decimal, that's 0.97, and then as a fraction, that's 97 over 100. There's no simplifying that can be done. Question 3, 2%, that's 0.02, and then as a decimal, that's 2 out of 100. I can divide top and bottom by 2, which is going to be 1 over 50. Question 4, 12%, that's going to be 0.12, and then 12 over 100, you can simplify by dividing top and bottom. So let me just quickly show you 12 over 100. I can divide by 2 first, or I can actually divide by 4 straight away. 12 divided by 4 will be 3. 100 divided by 4 will be 25, so it's going to be 3 over 25. Question 5. Write the fraction or decimal as a percent. So 27 over 100 as a decimal, write the fraction or decimal as a percent. So 27 over 100, that's 27%, fairly simple. Question 6, we have 0.82, that's 82%. Then question 7, 0.7 is 70%. And then question 8, 3 over 5, how do we change that into a percent? So 3 over 5 equals to something over 100. 5 times 20 is 100, and then 3 times 20 will be 60 over 100, and so that is equal to 60%. Okay? Continuing with question 9 over here. So let me write down question 9. It says order the numbers 34%, 8 out of 25, and 0.37 from least to greatest. I need to change them all into one common type, so either as all as percentage, all as fractions, or all as decimals. And so I would think the most simple thing is to change them all into percent. So first we have 34% as it is, and then we have 8 over 25. 8 over 25. I want to change that into a percent, so change that to over 100. That's going to be times 4 and times 4. So 8 times 4 will be 32, which is going to be 32%. And then the last one, 0.37, is 37%. Let me just write 0.37 equals to 37% over here. And so now we have to order them from least to greatest. So the least will be 32%, which is 8 over 25. So we're going to write 8 over 25 here as the first one, that's the least. And then the second one is going to be 34%. And then the greatest one will be 0.37. So that's how we order from least to greatest. We want to change them all into the same common type of number. Question 10. Find the simple interest for the given principal, rate, and the time. So the interest, find the simple interest will only be the interest value, not the overall value at the end. It's not the amount of money borrowed and returned or something like that. It's just the interest itself. So we have, if you remember, interest is equal to principal times the rate times the time. So I used a different notation. I used I as R before, the interest rate as I, but here it says the rate is R, but it shouldn't change. So if you got that mixed up, then yeah, just use common sense, in which you need to multiply the rate by the principal, not the, yeah. So anyways, we have here $375 times the rate, which is 7%, 0.07 times 3 years. And so I would allow you to use calculators for this because, or if you want to be hardworking, you can multiply this out by hand, but I will just use my calculator. 375 times 0.07 times that by 3. So this is how you would put it into your calculators. Can you guys see over here? Yep, like, whoops, like this. So it's 375 times 0.07 times 3, like that, and then click EXE in the end. Sorry, wrong number, I can't see. Press EXE at the end over here, then you would get $78.75. So that's the interest. 78 point, whoops, what did I do? $78.75. That's the interest, I. That's the interest, whether it's earned interest or whether it's interest you have to pay. Question 11, so we do the same thing. I is equal to 215 times the rate, which is 0.03, times the time, which is 5 years. So all you have to do is enter all of that into your calculators. That's 215 times 0.03 times 5. Then you would get $32.25. Last question, question 12. It says here, your bill in a restaurant is 28.7. You want to leave a 20% tip. Estimate the amount of the tip. Now, I don't have to estimate, I can find the exact, but if you want to estimate, 20% is double of 10%, and we know how to calculate 10% very easily. 10%, so I will just show you my thought process in writing. So 10% of 28.7 is $2.87, and so that means 20%, all I have to do is double that. 20% is going to be 2 is equal to 2 times that $2.87, and so that will be $5.74. $5.74. And yeah, so 87 times 2 will be 160, plus that 7 times 2, which is 14, which will be 74. So 5.74. That's the tip amount. So yeah, estimate the amount of the tip. That's $5.74. Now, moving on to the problem solving. Hopefully you have all done the problem solving already. If you haven't done the problem solving, then please do the problem solving questions first, and then you can go through the answers with me right now. Question 1, you want to invest $250 until the sum of the initial amount and the simple interest earned is between 400 and 500. Find a combination of a specific number of years and an interest rate between 1% and 7% that will allow you to achieve this goal. So first of all, you have $250, and then the interest earned is between 400 and 500. So 250 times some interest rate. I used I in my lesson before, so I'm going to use I again here. That's the interest rate times some sort of years that will earn me 400, between 400 and 500. So let's just say, at least 400. I'm just going to say 400 for now. And what I'm going to do is I'm going to just do some trial and error. So let me say my interest is 5%. I'm just going to give a good guess. So let's just say 5%. So 250 times 0.05, that's 5%. And then it says anytime a specific number of years. So it doesn't tell me how many years. I'm just going to say 5 years for now, just to see what number I will get. So 250 times 0.05 times 5, that will give me $62 only. So that's nowhere near enough. So let me think from here. If 5 years will only earn me $62, 10 years will be double of that, which will be $120 around. That's still not enough. I still need to be way more. And so let's use the maximum interest there is. That's 7%. And let's just put 10 years to see how much we will get. So $250 times that 0.07. Okay, 0.07, and then I want to multiply that by 10 years, and let's see how much interest we will get. 250 times 0.07 times 10, that will give us 175, which means that we'll probably need 25 years in order for the simple interest to be between 400 and 500. Let's try that. Let's try 25 instead. I'm going to change the numbers to 25. That's going to be 250 times 0.07 times 25. That will give me 437.5, which is the amount we want. Okay, so of course there is more different, there are many different combinations that will work. You can use a smaller interest with a longer number of years, but I'm just trying to achieve the fastest, so I use the higher interest rate. Question 2. The bar graph shows the result of a survey in which students at Hopedale Middle School were asked whether they wanted a bald eagle or a cougar, a hornet, or a buffalo as the school mascot. And so these are the results shown over here. These are the results. And so find the percent of students that want each animal as a school mascot. So each of the animals we want to find out. So first of all, we want to know how many students were surveyed. So total students, first we need to find out that, because we want to find a percent out of the total number of students. That's going to be 24 plus 18 plus 21 plus 12. Those are the total amount of students that were surveyed. And if I put that into my calculator, 24 plus 18 plus 21 plus 12. I'm just doing this quickly because I don't have too much time for this video. I know I'm already going over time, but I just want to do as much as I can. And so that's 75 students. And so bald eagle is going to be 24 over 75. I want to change that into a percent. So that's going to be 24 divided by 75. That's equal to 0.32, which is 32%. Then for cougar, we have 18 out of 75. And so change that into a decimal. 18 divided by 75, you would get 0.24, which is 24%. And then for hornet, that's going to be 21 out of 75. So 21 divided by 75, then multiply, that's 0.28, which is the same as 28%. And then lastly, for buffalo, we have 12 out of 75. So 12 divided by 75 will be, 12 divided by 75 is 0.16, which is the same as 16%. So that's part A over here. Then for part B, predict how many students in a group of 500 will choose each animal as their mascot. So we're going to use the percentage in part A to predict for part B for a group of 500. So for B, if we have 500 students, how many would choose bald eagle? So for bald eagle, I'm just going to do BE for short. That's going to be 32% times 500. So I can do 0.32 times 500, and that will give me a result. 500 times 0.32 is 160 students. And then for Cougar, I'm going to use C for short, that's going to be 0.24, that's the percent for Cougar, times that by 500, and then we will get 0.24 times 500, that's 120 students. And then for Hornet, H, that's going to be 0.28 times 500. Let me write that down, 0.28 times 500, which is 140 students. And then lastly, for Buffalo, that's going to be 0.16 times 500, and which will be 0.16 times 500, that's 80 students. Then for part C, would you use your prediction in part B to select the mascot, or would you have a vote between the top two selections? So this answer is open-ended. Now, what would happen if you only chose, the biggest one, bald eagle? That seems to be the most popular choice. But at the same time, we are neglecting all three of the other choices because they wanted something else. And so perhaps a more fair way to choose a school mascot rather than choose the top one straight away is perhaps you would choose between the top two, which was bald eagle and hornet. So I'm just explaining my answer. These were the top two. And then this will give these other 30% of, no, not 30%, the 18 and 12 out of the 75, which was Cougar plus Buffalo. So what percent? 16 plus 24, that's going to be 40%. So the other 40% of the students should still be able to choose their favorite out of the two. Of course, so that would be a slightly more fair way maybe. Of course, these are going into politics, but this is just discussing, why sometimes it's not the best to choose the top choice because the other people will not get to choose. Question 3. Sorry, not C. Let's just go straight to question 3. On their math quiz papers, John's score is written 22 out of 25 correct, and Vince's score is written as 84.5% correct. Sam's score is written as a decimal and is between John's score and Vince's score. So write two decimals that could represent Sam's score. So first of all, John, let's write that as a percent, as a decimal. 22 out of 25. 22 divided by 25 is 0.88. Okay, so that's writing 22 out of 25 as a decimal. And then Vince is going to be 84.5 is 0.845. And so for Sam's score will be somewhere in between. So any two decimals that are in between, so either we can have we can have 0.85, you can have 0.86, or we can have 0.87. Any of these three are fine. You can even put 0.5 as well. So 855, 865, 875, those are also fine. Question 4. You want to buy a $30 game and a $22 movie. You have a coupon for 20% off the price of any one item. How much more money do you save if you apply the coupon to the game instead of to the movie? So we want to first find out what the discount amount is for both of the game to compare how much more you save. So 20% off will be 20% of each of the movie and the game will be, first for game, 0.2 times $30. That will give you 0.2 times $30. That's $6. So that discount will be $6 discount. If we apply the coupon to the movie, that's going to be 20% times $22. That's going to be $4.4. Okay, so that's 2 times 22. Move the decimal back one place. That's 4.4. And then now what we want to do is we want to find out how much more money do we save if we apply the coupon to the game instead of the movie. That's going to be $6 minus 4.4, which is going to be $1.6 difference. So if we choose the same coupon, but we chose it for the game, the more expensive one, then we're going to save more money because we're getting a discount for the more expensive item rather getting a discount for the cheaper item. So hopefully you understand what that means. So the amount saved is $1.60. Then moving on to question 5. Again, feel free to pause the video anytime or go back if you don't understand any place or if you need to catch up. I'm just going to continue going on because I know this is going to be a YouTube video and I know this video is going to be long. Mr. Chow tends to talk a lot, but I want to go through all questions, which gives you the chance to check your answers for all of them. Question 5, use the figure below, write the ratio of shaded sections to all sections. So that's 1, 2, 3, 4, 5 shaded sections. So 5A, that's going to be 5 to how many in total? There's 8 in total, so that's 5 to 8. Then B is the part of the figure that is shaded greater than or less than 87.5. We want to write 5 to 8 as either a fraction and then change that into a percent. Let's write that as a fraction first. So that's going to be 5 over 8. That's going to be, write that as a, change that into decimal. So this time I'm not going to use my calculator. I'll show you how to do that by hand. So 5 divided by 8, 8 goes into 5 0 times. So we're going to add a 0. Then that goes into it 5 times. That's 6 times. That's 48. And then there's 2 remainder, 8 goes into 20, 2 times, that's 16, and then there's 4 remainder, and then that's going to be 5. So 0.625, and then change that into percent, that's equal to 62.5%. So, is the part of the figure that is shaded greater or less than 87.5%? That's way less. That's less, unless I made a mistake, right? 5 shaded out of 8, that's 0.6. That's 60. Yeah, so you would answer it. 62.5% is less than 87.5%. That's way less. So in order for us to modify the diagram to represent 87.5, 87.5, let's shade 7 out of the 8 squares, I guess. So for C, if we shade 7 of them, that's 7 over 8. So once you do the same thing, 7 divided by 8, 8 goes into 7 0 times, add a 0, so 8 goes into 7 8 times, that's going to be 64, and then that's 6, and then you add the 0, 8 goes into 60, 7 times, 8 times 7 is 56, and so there's 4 remainder, so that's 87.5, 87.5. So we want to change the diagram so that 7 of the boxes are shaded rather than just 5. Question 6. The gas gauge in the car indicates 25% of the gasoline has been used. Okay, keep that in mind, has been used. Now, since the last tank was last filled, write a decimal, the percent of gasoline that is left in the tank. So if we start off with 100% and 25% was used, how many percent of the gas tank is left? So first of all, 100% of the gas minus 25% that has been used since the tank was last filled, then that's going to be 75% left. Then we write that as a decimal. That's going to be, as a decimal, the percent of gasoline that is left, that's going to be equal to 0.75 of the gasoline tank is left in the tank. Question 7. Your street's community garden is a 10-foot by 12-foot rectangle. I'm going to quickly draw a diagram that's 10 feet by 12 feet. And your neighbors plan to enlarge the garden by extending the 10-foot length by 3 feet and adding a 12 foot by 3 foot rectangular section to one end. So we want to add 3 feet to the length over here, and then we want to add a 12 foot by 3 foot rectangular section at the end. So we're going to add an extra 12 by, so we're going to add 3, so this is originally 10, and then we want to add an extra 3 feet at the end. That is the 12 by 3 foot rectangular section at the end. Okay, so yeah, so this is the scenario. This is the original garden, and then we're gonna add this part to the end. So first, draw a label diagram of the old garden with the new section added. So there we go. A, I've already done that without even looking at question A. And then for B, write the ratio of the perimeter of the old garden to the perimeter of the enlarged garden in simplest form. So first of all, the perimeter of the old, so old perimeter is equal to 12 plus 10 times 2. That's the perimeter of a rectangle. 12 plus 10, that's the old one. So that's going to be 22 times 2, which is 44 feet. And then the new perimeter will be equal to 10 plus 3. We added 3 to the 10, so that's going to be, the 12 stays the same, but the 10 now turns to 13, times that by 2. That's going to be 12 plus 13, which is 25, times 2, which is 50 feet. And then we want to write a ratio of the perimeter of the old to the perimeter of the new one in simplest form. That's going to be 44 to 50. Then we can actually write the ratio as a fraction instead. So that's 44 over 50. We can divide top and bottom by 2. That's 22 over 25. Sorry, that's in simplest form. Then C, what percent of the perimeter of the enlarged garden is the perimeter of the old garden? So we want to find the new according to the old. So that's going to be new one divided by old one. So the new garden is 50 feet, and then perimeter of the new garden of the old garden. So what percentage of the perimeter of the enlarged garden is the perimeter of the old garden? So we want to find the something percent of new garden, which is 50, is equal to the old garden, which is 44. So we want to find, that's going to be X percent times 50 is equal to 44. So think about it this way. What percent, that's going to be what percent, and then times will be of 50 is the new garden, because it's the enlarged garden, of new garden, is the equal is the perimeter of the old, like this. Okay, so what percent of new is old? Then we can translate that into X percent times 50 equals to 44. Then how do we find the X percent? We just have to divide 44 by 50. So that means that the X percent is equal to 44 over 50. And then we can change that to out of 100. That's 88 out of 100. That's going to be 88%. Okay, and so that's how we find the percentage of the enlarged garden is. So 88% of the enlarged garden is the old garden. What does that mean? Physically, what does that actually mean? So if I'm going to draw a diagram of the new garden, this is going to be 12 by 13. That's going to say 88% over here. That's 88%. 88% is actually the old garden. Okay, so hopefully that makes sense. Sorry for the extra long video today. Hopefully you guys check all your answers, and I'll see you guys next time.